Hey everyone, welcome back to another video wherein we are going to solve a new question of trees. It's a very good question, I would say, and we will be understanding some new concepts. Basically, it's a very straightforward question. If you have done another questions of ancestor kind of a thing, you must be able to understand this question in just a very quick way. So basically, what problem statement is trying to say is that we just have to get the difference. We have to get the maximum difference between the node and the ancestor. So that means whatever the previous nodes, whatever the ancestors of a particular nodes are, we have to take the differences and we have to keep on calculating throughout the tree, and whatever the maximum value which is going to come at the end, that is something which we have to return, right? So over here I would say that you just need to understand the flow of this particular question. It's a very in terms of logic, it's a very easy question, but at the same time it's mentioned as a medium level problem. Okay, so just to show you the difference, the examples which are given to us, as you can see that this is particularly the tree which is given to us, and they have considered that 8 minus 3, right? These two nodes on the left hand side, 8 minus 3 is 5, and what they have calculated next is 3 minus 7, that is coming as a 4, and 8 minus 1, what is it? 8 minus 1, so this is the root node, and 8 minus 1, that is going to give us the 7. So I believe that's going to be the maximum value where that will be possible for this particular tree. So it shouldn't be the case that you are calculating the difference of the siblings. So we should be keeping in mind that we are calculating the difference of something called as the ancestor, right? So whatever the parent that we have for a particular node. So this is what the question is demanding, and you don't need to worry about the sign over here. We just have to take the modulus over here. So whatever the maximum value which is coming, we have to return that. So that's pretty much the question is. So I would say that if you know the recursion, just follow the leap of faith, like recursion leap of faith, and you can just go on with the flow of this question. So you can take the traversal over here, like you can take the in-order traversal and keep on just moving to the left hand side or to the right hand side, understanding the point of in-order traversal, and basis on that you just calculate the differences, like whatever the node is coming and whatever the maximum or the minimum that we have throughout the traversal till the time we reach out to the leaf node, and we just keep on calculating the differences, and whatever the maximum value which is coming, we will keep on updating our global variable, and whenever the maximum value is going to come, that is something which we have to return at the end. Okay, so that's what the problem statement is, and that's what the logic over here is. So let's try to code this, and we will see what's going to come at the end as the answer. Okay, so okay, let me just expand the screen. Okay, so I hope my screen is visible now, and we will be just starting with the logic over here. So basically this is the same thing that we're going to be doing over here. So I'll just assign a global variable. I'll say this is as a result. So that is something which we'll keep on updating over here, and that's going to return our answer. Okay, so for that thing, after that, let's go inside of the main method, the maximum ancestor difference. So over here, what do we need to do? So for very first thing that we will be checking is the like if root is equals null, then we just straight away can return something called as 0. Yeah, that's pretty much it. Like if the root is null, then we don't need to worry about, we just have to straight away return the null. After that, we'll be just taking a helper function so as to compute the things that we want to, and we will call this method so that we can compute and we can provide the logic that we want to build for this question. And at the end, we just have to return something called as the result. So that is the global variable which we have assigned initially, and once the answer is going to come, like we'll keep on updating in the helper method itself, and at the end we're just going to be returning that particular result answer for this particular question. Okay, so what do we need to pass for this help inside of this helper method? Firstly, we'll be passing on the root node that we have, and we'll also be passing the root value. So let me show you one thing. Let me just first of all write this down, and then I will explain what exactly I've done over here. Okay, so over here I've passed the root value for 2 times, and let me show you how I'm going to be defining this method. So I'll be defining this method as a void, return type as void, because we are not going to be returning anything from this method itself. We just keep on updating the result value that we have assigned globally, and that's going to be like something called as our final answer. So something called as tree node, like this is my root node that I'm going to be taking, and I will be taking two parameters. One is the maximum value and one is the minimum value. So we'll be using these two values. So what's going to happen over here? Okay, so let me explain you. So once we are on any side of the tree, like just imagine for a case, this is the root node, right? This is the 8 number, which is our root node. And if we are on the left hand side of this particular tree, right? Just take for instance, we are on the left hand side of this tree. So over here, what will be the maximum value? I'm just considering the left hand side of this particular tree, okay? So inside of this, the maximum value will be my 8 number. That is the root node. So that's not going to change. So even if I will be just taking the difference, okay, for this particular node, then for this maximum will be 8 and the minimum is something called as a 3. That is the root value itself. So that is something which I have to update, keep on while I'm traversing through the tree. And over here, when I'm reaching this particular point 1, right, I'm just keep on traversing and I've reached to this particular point, which is number 1, this particular node. So when I'm at this particular point, what will be the maximum value? So I'll also be updating my maximum variable so that I will be getting the maximum answer at the end. So if I'm moving over this side, then that means my maximum value which I have to consider is the number 8, not the number 3, because that is going to give me the more better answer, not this particular 3. 3 minus 1 is going to give me 2, right? But understanding 8 minus 1 is something which is going to give me the answer as number 7. So that means I have to consider this node, not this one. So that's the reason. If I'm traversing through the tree, I have to keep on updating my two variables, which is the maximum and the minimum, right? So that's the reason we have taken these two things over here. Okay. So once we are inside of the helper method, we are going to be starting with the logic that what we need to do. So we'll be using the in order traversal in order to compute and in order to go with the logic. So firstly, I'll just check on the same condition. If my root is equals null, that's going to be my base condition, right? So this base condition is going to just stop my recursion, like whichever I'll be doing over here. And after that, I'll be writing down the logic. So there is something called as my possible this is going to be my possible result that I will be computing every while I'm doing every single recursion. This is my in order traversal. So that means first of all, I will be checking the root node itself. Then after that, I'll go to the left hand side, and then after that, I'll go to the right hand side. Okay. So what it's going to do, it's going to be just keep on checking the possible answer that can come after every single recursion. Okay. So it's going to be checking something called as math.abs, and this thing is going to come. Okay, so what my possible result can be. So just imagine for a case that I'm traversing through this particular tree. I've reached to this particular 8. Then I have reached to this particular point 3 after first recursion. Now I will have to check the possible answer as if the maximum minus this particular node is the answer or not. That is something which I'll be checking after every recursion. So let me write down this particular step, then you will be able to get this particular point better. So math.abs, that's going to be done root.val minus max. This is the same thing that's going to be that's going to be checked with the minimum value as well. So this is something that we have to do. Okay. And after that, I will be storing this to the result, which is my final variable wherein I have to pass on my answer. Let me write down this step, then I will explain you what exactly is going on to the code to the point where we have reached. And this is going to be my possible result. Okay. So let me explain you this particular step, what we have done so far. Okay, so basically this is the very first thing that we have computed, which is my possible result. So possible result is something which we are checking after every recursion. So every recursion we will be checking that whatever the maximum value or the minimum value that we have got in a particular recursion, and we'll be keep on just subtracting with the root value, so that once we have reached to this particular 3, we will be having the maximum and the minimum as this particular thing. So we'll be checking that with the this particular point with this number 8, and so 8 minus 3 is something that's going to come over here as the number 5, and number 5 will be checked once again to the result that we have stored so far. Like after going through with multiple recursion, result will be keep on updating, right? So at some point result will be having some particular value, and that will be checked once again with the possible result. If that can be the possible result, that may be storing some kind of a greater value than this result, right? So we'll be keep on checking with every single node, every single recursion, and that's how it's gonna just keep on updating the answer. Okay, so let me go further. And like I mentioned, we'll be keep on updating our minimum and the maximum value, so that we can have our answer stored. Okay, so that will be my max equals math dot max. And how do we compute? Minimum space root dot. Okay, this will be my max root dot val. Okay, once that is done, we'll just start with the normal in-order traversal, and we'll be keep on calling this helper method again and again, and this time we'll be passing the new updated values. So this will be my root dot left as per the in-order traversal, and next thing will be max space minimum. After that, we'll be calling the helper method once again, and this time for the right hand side of the node, and again we'll be passing the max, the updated one, and the minimum value, so that we can get the answer. Okay, so this is what the code is over here, and this is a very simple code. This is a very simple logic. Just the in-order traversal is something that we are doing, and we are keep on updating our possible result, like after subtracting it through the maximum and the minimum with the root values, because that can be the case that we have our answer in our hand, and that will be checked once again with the result variable, and then we are just following up with the in-order traversal. So you just have to go with the leap of faith of recursion, and we just have to keep on computing, because the in-order traversal is not gonna let you comparing these two siblings. It will keep on going through a particular strand of a tree, and it will keep on just computing with that particular what do we call that, strand, or you can say the branch. Okay, so it's gonna keep on going in that direction only, and it will just compute the answer. So let me just run this particular code. Yes, it is passing the test cases. So as I'm going to be submitting this answer, yep, it's perfectly working. So yeah, you can see that it's a very simple code, and I hope I was able to explain the logic. If you have any kind of a doubt, because it's just a recursion, if you have done enough of the problems of the tree, then it's just the recursion and just the basic understanding. If trees question are just like this, the code is pretty simple. If you know the logic, then you can just write down the code in just 10-20 lines. That's pretty much it. Over here as well, you can see that it's not a very lengthy code, just the logic was required. If that is clear, you can just write down the code, and simple in-order traversal was there. So yeah, that's pretty much it from my side. It was a quick tutorial, and it was a quick question. If you have any kind of a doubt, you can put that in the comment box, and I will try to give you the answer back. So yeah, that's it. Thanks for watching. See you next time.